Hello everyone, welcome to our series Paper and Profit Part 2. This is your Suraj. Let us understand why it is so important. Hello everyone, welcome to our series Paper and Profit Part 2. This is your Suraj. Let us understand why it is so important. In the first part, we have explained so many things. It is basically a chemical treatment of the raw material utilizing the patented process. So, recap of the part 1. The main objective is to increase the yield of the pulp and reduce the black liquor solids quantity. As the yield increases, wood consumption reduces for the same pulp production capacity along with the reduction of black liquor solid quantity. Black liquor solid quantity increases due to the pulp degradation only of worth rupees 40,000 rupee per metric ton along with the high cost of chemical consumption and steam consumption. Conventional process need to be upgraded with this chemical treatment so that high strength pulp can be produced, which in turn will help to load more ash over the paper machine so that overall cost of the production be reduced. So now, as I told in the previous version, how much it will cost to invest, how much it will cost to install this plant, and how to we calculate the economies related to it. So, in conventional system, if you go for the expansion, you will find that it requires almost 3 crore rupee per metric ton capacity augmentation. So, in this sense, suppose you have 400 metric ton capacity production per day and you are thinking to increase by another 400 metric ton production. So, the requirement of the capex will be 400 into 3 crore rupees. So, another thing to be noted down here that though you have invested this much rupees, the cost of the production will remain the same. At the same time, the interest cost will increase by conventional way. Now, come to the another patented technology what I am talking about. Equipment cost will remain as such, and the new equipment which need to be procured, fabricated, or to be installed, it will cost approximately 0.25 crore rupee per metric ton pulp production augmentation. So, in this sense, if 400 metric ton per day production increases, the capex requirement will be 400 into 0.25 crore rupees. It means 100 crore rupee will be required for the 400 metric ton per production augmentation. So now come to the another point. Does 50% yield is practical? Yes, it is practical. Look, these are the some of the composition of the various raw material. Suppose if we have this wood chips, you will find that ash content is 0.5% and cellulose and hemicellulose is approximately 69 to 70%. It means that at 100% capacity, at 100% efficiency, 69% of the yield, 69 to 70% yield, average yield is possible. But practical yield 50% is must be done. Similarly, if you come to the wheat straw contains 25% of the lignin and 70% maximum yield is possible, and practical yield is 50% must be there of bleach pulp I am talking about. Similarly, in case of bamboo chip, 70% of the yield at 100% and practical yield 50% should be there. Similarly, in the bagasse, 50% yield is possible, and in case of rice straw, this technology is uh, this technology is itself is sufficient to remove the silica in the rice straw also. So up to 95% silica can be removed, and rice straw is abundantly free in abundantly available in our country at lowest possible cost. I will come to in further slide how to remove the silica from the rice straw. Let us move to the next part. So how it is get done? Chemical pulping is basically a dissolving process. The main duty is to separate the fiber from the lignin selectively. So our process must be in such that it should not have impact on fibers. It must not damage the fiber. Second, NOH is the strongest alkali. High amount and high temperature create more damage to the fiber. Point number three, the sodium carbonate is a weak alkali. It does not create ample damage to the fiber when chips of bamboo or hardwood is dissolved in the Na2CO3 solution of concentration 5 to 10%, and even some degradation seen, but it is only after 48 of hours. Otherwise no further degradation usually is observed. So Na2CO3 makes swelling of inner walls and lamella of the wood chips and bamboo chips. So fiber segregation becomes easy. Na2CO3 is excellent chemical to leach out silica, calcium, magnesium, phosphorus, and so many non-process element along with swelling of the chips and the raw materials. Now methodology and assumption. First case is the hardwood. Each raw material has its own bulk density and its own retention time in Na2CO3 solution at its own concentration. Wood chips and bamboo chips need to be soaked in such a way that retention time is at least 20 to 24 hours. Wood chips and bamboo chips is after the soaking, wood chips and bamboo chips are grind at slow RPM so that there is no damage to the fiber. After grinding the raw material, the surface area of wood chips and bamboo chips increases and the bulk density decreases. But if you see, packing density will still remain the same due to availability and the moisture content within it. As the it is drenched properly in the solution, so no trapped air is left anymore. Post grinding, material may be opted for the alkali neutralization by dilute H2SO4. Actually, H2SO4 is neutralization is important from rayon grade type of pulping, which removes the metal ions, acid insoluble, and other non-process element which is necessary. Similarly, when acid neutralization is performed, this pulp becomes excellent. Brightness and specks, dark spots, all gets removed from the raw material itself. So, post grinding all type of raw material to be cooked in the respective digester at respective cycle time. Post alkali neutralization, this maybe go into a evaporative type of digester with cooking chemical just 8% in case of wood chips and bamboo chips in first stage. I'm not talking about right now of vitro and bagasse. I will come to that point also. At that time, in case of agro-based raw material, the alkali requirement will be even lesser. Due to this process, cooking time of hardwood and bamboo chips is expected to be reduced by 50%. Means if our cycle time is 5.5 hours to 6 hours, now it will be maximum 2.5 to 3 hours. After first stage cooking, all the liquor from the digester is taken out from the mash inbuilt in the evaporative type of digester. So so that uh, uh, so that viscosity and other parameters will remain as intact. Now, because the most of the black liquor is taken out, a fresh dose of white liquor is or cooking chemical is sent into the digester, because lignin is more dissolvable in the white liquor and NOH. So it removes the remaining lignin from the digester itself. Due to removal of the lignin, due to removal of the lignin, um, uh, kappa number of the kappa number of the material reduces, brightness increases, which is the prime objective. So the system is designed in such that even brightness start to increase from the first washer itself. Now come to the point number B. Visra and bamboo to be soaked in such that the maximum retention time is 30. So if you note that one raw material is hardwood, which is require more soaking time as compared to this agro-based raw material, because its bulk density is low and its surface area is more. So more surface area of the material is required to have a faster cooking. After alkali soaking, raw material may be opted for the acid neutralization or alkali neutralization by the dilute H2SO4 stage. Post alkali neutralization, raw material may undergo to the evaporative digester instead of screw type digester. Why evaporative digester is required? Because I will explain in the coming part. This evaporative type digester utilizes vapors of the digester to evaporate the black liquor into strong black liquor. So you need not to utilize live steam into the evaporators. So in nutshell, previously in conventional system, pulp mill used to produce black liquor of 15% solid, which was sent to the recovery for evaporation, where it asked for the live steam LP or as well as MP to evaporate up to it to 65 to 70%. Here the whole energy given to the digester itself will be sufficient to evaporate. So finally we will have to just fire the SBL in the recovery boiler. Further, no new steam will be required for the recovery part. So after first stage cooking, all the liquor will be taken out similarly as done in the hardwood case, and from the strainer, and a fresh dose of white liquor will be dosed, so that to remove the residual lignin from the digester itself due to pressure difference, because all the line is connected in such that by the on of wall all the liquor will be taken out from the strainer itself. So lignin will reduce from the pulps, and delignification start from the digester itself, as well as brightness of the pulp will also increase along with the reduction in the kappa number. With the same time, kappa number will reduce, but the same time strength of the fiber will remain intact. Now learning and crux. 100% yield is not possible, it is known to everyone, but in pragmatic approach, say 10% loss of the pulp is acceptable. Means if our pulp is 70% in the raw material, so 60%, 55 to 60% of unbleached pulp yield is required, and 50% bleach pulp requirement is the topmost requirement as to compete the market. Increased pulp requirement for the meal is the most important requirement of the meal to enjoy the economic of scale. In the coming part, we will explain you how the evaporative digester is and how it works, so that you could understand where our actual profit is hidden. Till then, bye bye.